Hello viewers, today I will show you how to make box plot in one-way ANOVA in CRE design. Yesterday I showed you how to analyze your data, one-way ANOVA data by using 2K SSD test. So today I will show you how to visualize this data in Boxplot. Let's start. Okay, so today I'll show you how to do box plot. So here first we have to summon box plot function, box plot, and in box plot you have to use the dependent variable, independent variable, what will be your x, what will be your y axis and x axis. I'm gonna show you. Our dependent variable was pH, that is the plant height. Then we use tilde this tilde, and then our dependent one is treatment only treatment. Bear in mind, always we use tilde. In right side of this tilde will be the independent variable, that is here the treatment is independent variable, and in left side, that is the plant height, which is dependent variable. Okay, then plant height selected, and our data will be data as yesterday, as our previous video I showed you. And then we can fixed control the y limit. Then what will be our y? So we can use C function, and we have to use the minimum and maximum value of y axis or y limit. So our minimum will be minimum data $sign plant height, minimum plant height -2. Why -2? Is minimum plant height below 2 will keep, and then what will be the maximum will be, maximum will be data $sign plant height, maximum will be +2, that is above 2. So we have some space, that is the limit. And then okay, then we can label x labeling, x labeling will be treatment. We can treat it as treatment. This is the name of x axis, and then y labeling, y axis will be named as plant height, right? Sorry, plant height in centimeter. Perfect, centimeter. Okay, and what will be the color? You can use color. Okay, so you can use color red. Okay, let's see. This is our box plot in the right corner. You'll see here the control, salinity and salinity arginine, these three are my treatments, and plant height in y-axis. But I want to change the color. For control, one color, for salinity and another color, and for salinity arginine another color. It's so simple. What we can do, we can use here color and then C function. So for control we can use green, and for salinity we can use blue, and for salinity arginine, black. Okay, black, perfect. And then let's see, yeah, color already changed, so you can easily do this. Then I want to put the letters, that is the two key groups letter here, so we need to add letters in our plot. We found the plot, but we don't know how to add the letters in this box, so I'll show you. Before doing this, we need to extract the letter. So in first step, we have to extract the letter. Extracts letters, and then also fix the treatment, that is the, we have to fix which are my treatment, and then we have to choose the maximum value. What will be the maximum value, and the treatment order, and then letter vector, what will be the our letters vector. Yeah, these we have to do this stuff, so I'll show you from the very beginning. Okay, so let me check again our grouping, 2k $, groups, perfect. Yeah, you can see here we find control, salinity arginine, and salinity, normal salinity. So these are the three groups, A, B, and C groups. But we have to extract the row name, that is our treatment is row name, not column. Row name is our treatment, so we have to identify our treatments, that is the treatments. I use it in small letter so that it will not treatments, right, so it will not mix with that treatment will be only the row name, row names, perfect. Row names of 2 key, just row names of these 2 key groups, perfect. The row name, perfect. So our treatments already denoted. Then what will be the maximum value per treatment? So maximum value, max values, max values equal, no sorry, max values will be maximum values. Here we have to apply a function to subset of this vector. To subset different vector, we have to apply a apply function so that we can easily find the maximum value to put here. So we can use tapply. Why we need this tapply? You can check here. Tapply will be the x is our numerical value, that is our plant height, and that index is the grouping, and fun is function. Here the function is maximum, so we can use this to subset this vector. We need it for maximum value extraction. So t value, first data, $, plant height, numerical value, bear in mind, then group. So data and group is treatment, and then we need maximum function, that is we need maximum value, so max. Okay, perfect, right. So we have done this maximum value, and then we need treatment order, right. We have to extract treatment order. What will be our treatment order? Perfect. Treatment order will be so we can use another function, labels. So we have to label our treatment groups. We find 3 groups. We have to label this, which one is for control, which one is for salinity and arginine, which one is for salinity. We have seen this in 3 groups. So we have to label these three. Okay, so label data $sign treatment. Perfect. So we arrange the treatment order. Then what will be the letter vectors? Letters vector. So add it out here. Letters vector will be we find this letter from two key groups. So two key groups you can write here or simply copy paste two key groups, and then square bracket square two key groups of treatment order, right? We arrange these groups in treatment order, right? You can use this treatment order, right? These are functional group. And then we need treatment order perfect, and then you have to group this UPS groups, right? Done. Okay, then we can add the letter, that is the add letters. Now we can add letter. Now we have to use another function, that is the print text, then use for x-axis. X position will be, first we have to sequence along, okay, to sequence the treatment order. So sequence treatment order, right? In x-axis have treatment order, sequence treatment order. Then what will be the in y-axis? In y-axis we will use the maximum value of the treatment. You have seen this is the x-axis treatment order. In y-axis maximum value of our treatment, here maximum value. So we use the max values, then square bracket maximum values of treatment order. We already denoted treatment order as the treatment, all the data in treatment, to make it in arranged maximum value treatment order, and we need it to be little bit upper, so plus 0.9. you can use it to 1.5, but we need some space between the letter and our box plot. That's the reason I will show you. And then we need now label, final labels. Labels will be our letter vector. This is our label, this will be our letter vector, right? A letter vector. Perfect. Let's see. Okay, finally we find that our letters are fit with Boxplot. A for salinity, A for control. Here you see A for control and it come in maximum, and B for salinity and arginine, and C for salinity. So from this video we learn how to draw box plot to visualize our data, and also how to add letters in our box plot. So the question what I told there, that if you use 0.9 to 0.1.5, it will be closer to here. So it's up to you. Thank you very much for watching.